This is one of my favorite problems in integration by parts because we're going to solve for the integral of e to the x cosine of x without actually ever really solving for it. And you'll see what I mean. It is going to cycle through by two applications of integration by parts, and we're going to be able to recover a formula for this integral. So let's start off with the original problem. We're trying to integrate e to the x times a cosine of x. So here, if you're thinking about what am I going to differentiate, what am I going to integrate, no matter what you do to e to the x, it will stay e to the x. And cosine of x is just going to bounce back and forth between sine and cosine, right? Give or take a plus or minus. So it really doesn't matter what you choose here. Let's choose to differentiate the e to the x function. And I will integrate the cosine of x function. So v is going to be sine of x. Du is going to be e to the x dx. So this integral, e to the x cosine of x dx is equal to uv minus integral v du. Okay, so we have another integration by parts right there. So we'll choose to differentiate the e to the x function again, and we will integrate the sine of x function. So v will be minus cosine of x. Du is e to the x dx. So this integral, e to the x cosine of x dx, is equal to e to the x sine of x minus, and this integral can be replaced by this integration by parts. uv minus integral v, so I'm just going to change that to a plus, v du. Okay, let's clean that up, make sure to distribute everything correctly. We have e to the x sine of x with a plus e to the x cosine of x and a minus integral e to the x cosine x. Okay, so notice I have an e to the x cosine x inside of an integral and a integral e to the x cosine x. So if I throw this over to the other side, I will have 2 integral e to the x cosine x dx is equal to e to the x sine of x plus e to the x cosine x. And now all I have to do to solve for the integral that I wanted is to divide that 2 over. So the integral of e to the x cosine x will be 1/2 e to the x sine plus e to the x cosine. And I realized I forgot my plus c's after I found integrals. So let's go back and add plus c's to everything. That c is just an arbitrary constant. It's going to change from line to line, but I'll just keep renaming it plus c.